Hey guys, so in the last video we saw how do we measure distances along great circles and what are the various models that could come in the exam. Now let's talk about how do we measure distances along rhumb lines. The distances that we measure along rhumb lines are known as departure. The technical word used is the term departure. Now the departure is the distance measured along a rhumb line between two points which are nearly at the same latitude or at the same latitude itself. Essentially, departure is the distance measured in east or west direction. Okay, so both the points have to be on the same latitude or nearly same latitudes. Then the distance between these 2 points is known as departure. Alright, and we know for a fact that going east or west, right? Going east or west, we will always form a rhumb line. Why? Because we are going to cut all meridians at 90 degrees, no matter where we are, right? Going east or west, we are always going to cut it at 90 degrees. Let's look at it here. Going east or west in any direction on the earth, is it not going to cut each meridian at 90 degrees? It is, right? No matter what it is. It could be the parallel of this latitude, it could be somewhere in the middle, but it will always cut it at 90 degrees, right? So we know for a fact that all latitudes and parallels of latitudes are nothing but rhumb lines, right? And distances measured along these latitudes or parallels of latitudes are known as departure. So before we understand how do we calculate departure, we need to understand what is d long. All right, just like in the previous class we spoke about what is ch lat, right? Change in latitude. What was the technical definition for change in latitude? It was nothing but the angular difference between 2 points, between two latitudes, right? That is what I was trying to find out. In the previous class we saw that if this was the center and this was our prime meridian and this was the equator, if we had 2 points, right, I was trying to find out the angular difference between them. I was trying to find out this angle, and then I used to apply some formula and convert this angle to a distance, right? Because going north or south, I would be traveling along a great circle anyway, right? If I'm traveling pure north or pure south, I would be traveling along a great circle. So the conversion from an angle to a distance was not tough, right? But what was I trying to measure? I was trying to measure the angular difference along a longitude, right? That is what I was trying to do. That used to give me what? This was my ch lat, or angular difference between two latitudes, right? Similarly, d long or difference in longitudes is the angular difference between 2 points along their longitudinal east-west lines, right? So what is d long? D long is what this angle is between the longitude I want and the second longitude. This is known as the difference of longitudes. Okay, I could be given this as longitude A and this as longitude B, then this becomes my d long, right? How much is the difference or angular difference between these two longitudes? Now please remember, we again, just like ch lat, we only measure absolute distances. Okay, so let's say we had both the points in the eastern hemisphere, right? We had to measure the d long between these two longitudes. What would I do? I would subtract them to find the middle angle, right? I would know this value, I would know this value. If I were to subtract the smaller one from the bigger one, I would get the remaining, that is the angle that is subtended between them. What happens if I am given one longitude in the western and one longitude in the eastern half? In that case, what do I do? It's very simple. Please remember, we only measure absolute distances. Okay, we measure the absolute values. So how much is the angle between them? The angle between them will be a sum of this and a sum of this angle, isn't it? And what are these angles? These angles are nothing but reference to our prime meridian. These are the values of our longitude. This is what we understood by the definition of longitudes in our previous class, right? These are angles subtended between what? Between the prime meridian and the point that has to be identified, right? These are angles subtended at the center, right? So these are angles subtended at the center between the prime meridian and the point that has to be identified. So whatever value we have of our longitude and whatever value we have of our western longitude, when we add them, we get the total angular difference between them. This angular difference is known as d long, right? Fine. So now that you guys have understood what d long is, you'll get a more refined idea of what d long is as we go forward. But for now, you need to understand that it is the angular difference between two longitudes. Okay? If you remember this basic definition, it becomes very easy for you to work with it. Fine. And what is departure? Departure is when we measure our distance in east or west direction, right? Just like we were using great circle to measure our distance in north and south direction, we use departure to measure it in east or west direction. Fine. Now, if you've understood this, you'll realize there's something very interesting. Okay, so let's understand this with an example. Let's say I were to measure, okay, I were to measure departure between these two longitudes. Okay, let's say I was traveling from point A to point B. That's point A to point B. So I would be traveling along the green line, right? So this is what I call as departure, right? Distance in east or west direction along a rhumb line. Fine. Now if you observe, even though I am measuring the distance between the same two longitudes, my departure goes on reducing if I travel up or if I were to even go south. So with an increase in my latitude, right, this increase could be going northwards, going southwards, because the values are 0 at the equator and they go on increasing towards the poles, with 90° north being at the north pole, with 90° south being at the south pole. So with these values continuously increasing, the value or the magnitude of my departure keeps reducing, right? Finally, here, the distance between the two longitudes comes to 0. Why? Because they all are merging at the same point, right? So the distance between the two longitudes, right, is 0, and at the equator it is the maximum distance they could be, right? The longitudes are maximum spaced at the equator. So departure, if you realize, is affected rather by the latitude, right? The distance between the same two longitudes will be maximum at the equator, but the distance between the same two longitudes, if measured at the poles, is going to be the least. So what do I realize from this? I realize that if I were to get some trigonometry in the middle, right, what is such a value which is maximum? Which function gives you maximum values at 0 degrees but minimum values at 90 degrees? It is the cos, is the function of cosine. So the formula for departure is departure, which is the distance traveled in east or west direction, or distance traveled between two longitudes, right, in the east or west direction along a parallel of a latitude, is given by d long, which is the difference in longitudes, into 60 into your cos of latitude, right? So d long is what? D long is difference in longitudes, 60 is a factor of conversion, and this is how we adjust it, right? Because we know it is continuously changing at a rate of the cosine of my latitude, right? If my latitude is 0, cosine 0 is going to give me the maximum value, and if I have my latitude as 90 degrees, my cosine is going to have the least value, and that is how departure is also fluctuating. So departure essentially gives you rhumb line distance, don't forget that, okay? Departure gives rumb line distances. Right. So let's understand this with a question. Okay. Let's say we have a point x which is 30 degrees 30 minutes north and 040 degrees 20 minutes east, and we have a point y which is 30 degrees 30 minutes north 060 degrees 40 minutes east. Okay, so if you observe, they both are on the same latitude, right? Unlike the great circle questions, if you notice, which were ya to they were on the anti-meridians, ya to they were on the same meridian, right? If you look here, they were on the same meridian. In rumb lines, because we are measuring distances along east or west direction and along parallels of latitudes, we are assuming that they both are on the same latitude, right? Or that's how the points are given. Only then can we measure rumb line distances or departure. So first thing we figure out, they both are on the same latitude. Then we are given two coordinates. We are given 40 degrees 20 minutes east and 60 degrees 40 minutes east. Both of these are longitudes. So now I have to find the d long between them, or difference, angular difference between the longitudes. So again, let's go back to our basics and draw the earth, right? I draw my prime meridian and I draw my equator, right? Then I draw both my longitudes. I draw my 40 degrees 20 minutes and I draw 60 degrees 40 minutes, right? Now I know they both are at the same latitude, right? This latitude is of 30 degrees 30 minutes north, right? Fine. Now this is 40 degrees 20 minutes east, or 040 degrees 20 minutes east, and this is 060 degrees 40 minutes east, right? Now I am told to find the angular difference between them. I have to find this, right? How do I find this? These are my points A and B, x comma y. Okay, now I have to find this. What is my d long? My d long is the difference of longitudes, which in my case, what do? I'll have to subtract it, right? I have to find the angle between them. So what do? I know that this value, whatever this angle is, measured from the prime meridian, is nothing but the value of my longitude, right? Similarly, the angle measured here is the value of this longitude. What am I supposed to find? I'm supposed to be finding this. So I could just subtract this one from this one. I could do that. So let's try doing it. Let's calculate our d long. So I could do 060 degrees 40 minutes minus 040 degrees 20 minutes. What do I get? 20 degrees 20 minutes, right? That is my d long. Again, you could use a calculator. If you want to practice doing it on pen and paper, we already know how do we do it, right? So we get 20 degrees 20 minutes as our d long. Now we are asked to find the distance between these 2 points, the physical distance, not the angular difference, but a distance. So how do we convert this? In terms of great circles, this was easy. We used to just multiply it with a factor of 60, right? Knowing that 1 degree is 60 nautical miles and 1 minute is equal to 1 nautical mile. We can't do that here. Why? Because we are not necessarily on a great circle when we are traveling like this, right? On the equator, it was absolutely fine. This was a great circle and this is also a rumb line. So calculate with departure or calculate with the into 60 rule, which we use for great circles, they would give you the same answer. But for us, it's not the case like that here, right? Because as we go up, the distance between the two longitudes is decreasing. Plus, we are just going to make small circles. So the factor of multiplying by 60 won't work. Hence, we have a formula. What does the formula say? Departure says d long into 60 into cos of lat. So what do you get there? Okay, you get 20 degrees 20 minutes into 60 into cos of 30 degrees 30 minutes. When you put this into your calculator, you get 1052 nautical miles, right? So this distance between point X and Y, which both lie on 30 degrees 30 minutes north, is 1052 nautical miles. Okay, that's what you calculated. So let's try doing another question. Okay, let's try solving this. Let's say there's a point X which is at 40 degrees 30 minutes south and 050 degrees 27 minutes east. And there's a point Y which is at 40 degrees 30 minutes south again, because same latitude in terms of departure, and 020 degrees 27 minutes west. Find departure. For those of you who have understood, you can pause the video here and try solving it on your own. Right? For those of you who have not yet grasped the concept, let's go over it again. So, departure is the distance measured between two longitudes, right? But at a specific latitude. Why do I have to say it like this? Why do I have to say distance between two longitudes measured at a specific latitude? Because the distance between two longitudes, right, the physical distance between two longitudes which are given, keeps reducing depending upon what latitude am I at. The greater my latitude, the shorter the distance, right? Why? Because my longitudes converge. It's a sphere ultimately, right? So they converge closer and closer to each other. Ultimately, they coincide at a single point, which is why the departure at poles is going to be 0, right? So, in our case, we are given that both of them lie at a 40 degree 30 minutes south. So, let's draw it here. So, let's say this is a 40 degree 30 minutes south latitude. Fine. Now we are told that fine, one point is in the east and one point is in the west, right? What are we told? One of them is on 050 degrees 27 east. So this one is 050 degrees 27 east. And this one is 020 degrees 27 west. Now, I am asked what is the angular difference between them? What is this angle now? What can I do? I just have to add this angle along with this angle. How do I know what's the value of this angle? It just lies in the definition of longitudes, right? Measured from the prime meridian, the angle subtended is what gives me the value of this longitude, right? So in my case, that would be 50 degrees. Okay, in my case, that would be 50 degrees 27 minutes, right? Similarly, it would be 20 degrees 27 minutes. I just need to add them to find the angular difference between them, the angle, right? It's just the absolute value of what is this angle. So, in my case, I would get that to be 70 degrees 54 minutes, right? So what did I get this figure? This is called as my D long. What was my D long? My D long is the difference in longitudes represented as the angular difference between 2 points along their longitudinal east-west line. So along my longitudinal lines, right, along this, when I measure the angle in east-west direction, whatever the angular difference is between two longitudes is known as my D long. So I calculated my D long to be 70 degrees 54 minutes. So what is my departure? My departure is D long into 60 into cos of my latitude, which in my case would be 70 degrees 54 minutes into 60 into cos of 40 degrees 30 minutes, cos of my latitude. This is the latitude I am at, right? Isn't it? So what do I get? I'll get, precisely when I put it in my calculator, I get 3234.676 actually, which estimated to 3235 nautical miles. Okay, so what have I calculated? I have now calculated that at this latitude, what is this distance? Okay, what is this distance in the middle between these 2 points? How much is this? I have calculated this line to be 3235 nautical miles. I hope that makes sense now. Okay, now the models in departure are very interesting. Okay, so let me write the formula down to explain you something. Departure is equal to d long into 60 into cos of latitude. So possible models that can come in departure could be any one of these. You have 3 variables. You have the value of your departure, you have the value of your d long, 60 is a constant number, and you have the value of your latitude. They could give you any 2 and ask you to find the third. So far we used to have enough information to calculate our d long, and we used to be given a latitude, and we used to be asked to calculate our departure. There could be a question where they could give us the departure and our latitude and ask us to calculate what longitudes are we at. What is the difference between our 2 longitudes? They would just give us a starting longitude and tell us, where do I end this? Which longitude am I measuring till? If I'm at so and so latitude and I'm traveling so and so distance, they would ask me to find my d long. Or they could give my departure and they could give my d long, and they could ask me, what latitude am I at? So let's look at these different models. Okay, and let's understand these through questions. So again, let's say the question says there's a point 40 degrees north, 020 degrees west. The plane flies easterly. Okay, easterly is on a heading of 090, and it flies for 1200 nautical miles. What are the coordinates of destination? So, looking back at our formula, what all have they given us? They have given us a starting point. They have given us, we know what longitude are we at least starting at. So we are starting at 20 degree west and we are going eastwards. We know this. We don't know what the latitudes are, right? But for a fact, we know that departure can only be calculated on the same latitude. So we know they both are going to lie on 40 degrees north. So latitude we have. D long, we need to find out. Departure is given as 1200 nautical miles, right? So let's try working with this. For every question, I will insist, please draw a figure. It helps you understand the concept and it helps you solve the question better. There's no margin to make a mistake then. So I draw my prime meridian as usual. I draw my equator. And then I am told that I am at some 40 degree north latitude. How do I know this? I know this from the information that's given to me of my latitude. Then I'm told that I start at 20 degree west. Okay, so this is my 20 degree west longitude. And they tell me that I fly eastwards. So they tell me that I start from this point and I fly eastwards. Okay, east is this direction, right? West is this direction. North is this, south is this. So I still fly eastwards. Okay, I fly on a heading of 090. Fine. Now, they told me that, okay, the length of this line, I travel along this, the length of this line at particular latitude is 1200 nautical miles. That means it has to terminate somewhere. If this is the starting point and I travel for 1200 nautical miles, it will stop somewhere. They're asking me what are the coordinates of this point. So let's assume that I do not know what longitude is this at. Okay, let's say I don't know this. Unknown. I already know my latitude, I just need to find my longitude, right? Which is essentially what I said, we need to find our d long, right? So let's put it back in the formula for departure. So departure is equal to d long into 60 into cos of lat. What is departure equal to? 1200 nautical miles. What is my d long equal to? I don't know, right? What is my cos of lat? Cos of 40 degrees. So 1200 divided by 60 is equal to d long into cos of 40 degrees. I know for a fact that this is equal to 20. So 20 is equal to d long into cos of 40. When I calculate and put these values in my calculator, I get my d long to be 26 degrees 6 minutes. Okay, fine. Now let's go back to what is said in the question. The question says that I start from this point and I travel eastwards for 1200 nautical miles. So now I converted the 1200 nautical miles to an angle. How much is that angle? The angle here is 26 degrees 6 minutes. So they tell me starting from here, I continuously fly making an angle, a total angle of 26 degrees 6 minutes. That is my d long, or difference in the two longitudes is of 26 degrees. The absolute difference is 26 degrees. So where have I ended up? So let's do this logically. If I start from 20 degree west and I travel eastwards, by the time I reach the prime meridian, I have already finished 20 degrees of traveling, right? This is from the definition of longitudes. Then I have to travel an additional of 6 degrees 6 minutes to complete a total angle of 26 degrees 6 minutes, right? So I cover 20 degrees to reach the prime meridian. From there on, I only have to travel for 6 degrees 6 minutes to make a total angle, or to get a total d long of 26 degrees 6 minutes, right? So from 0, I have to travel 6 degrees 6 minutes. That is nothing but 6 degrees 6 minutes east, because I'm measuring from the prime meridian itself. So what are my final coordinates? My final coordinates would be what? 40 degrees north, 006 degrees 6 minutes east. Isn't it? Right? Now, I hope you guys understood what are we doing here. Now, let's look at another model. It's essentially the same model, just adding a layer of complexity to it. Okay? So, the question says, we are flying from a point which is 20 degrees north and 020 degrees east. Okay? And we fly on an easterly track. On a westerly track. We fly on a westerly track for 5 hours 30 minutes. Our ground speed is equal to 420 knots. We have to find coordinates of destination. How do I do this? Essentially, they have just given me the time and my speed, right? Departure is the distance. In my previous question, they had already given me the departure in the question, saying it's 1200 nautical miles. Here, I have to calculate what the departure is, knowing how much time am I flying and what speed am I flying at. So I know if I fly at 420 knots for 5 hours and 30 minutes, how much distance am I going to cover? I'm going to end up covering 2310 nautical miles. So this 2310 nautical miles is my departure, or distance traveled in east-west direction. Fine. So they're telling me that I'm traveling west for 5 hours 30 minutes at so and so speed. So distance is equal to speed into time. So I calculated how much is this distance. I got it as 2310. This distance that I travel at specific latitudes in east or west direction is what I call departure. So they're essentially the same thing. So I fly for 2310 nautical miles. From there, let's go back just the same way what we did in the previous question, right? We have a globe, we have a prime meridian, we have an equator, right? Now they told us that we start from some 40 degrees. What do we start from? 20 degrees, not 20 degrees east, right? So this is the 20 degree east line, and let's say this is the 20 degree north latitude. So 20 degree north latitude and 20 minutes east. So I start somewhere here, and they say I fly westwards. I fly westwards for how much? For 2310 nautical miles. So let's say this 2310 nautical miles ends somewhere here. So they are asking me what is this angle, just like the previous question. What I have to calculate my d long, right? So departure is equal to d long into 60 into cos of lat, right? So what is my departure? I calculated it to be 2310 nautical miles. D long is unknown, 60 is constant, cos of 20 degrees. So D long, if I rearrange it, becomes as 2310 divided by 60 into cos of 20 degrees, right? So when you solve for this, you will get D long to be 40 degrees 58 minutes. Fine. Now 40 degrees 58 minutes is this whole angle. I want to find out what is this longitude. So fine, the same logic, okay? A lot of books will tell you minus, minus, plus, plus, a lot of formulas and all. Let's keep it very simple. We are going to travel westwards, so towards the prime meridian. So I for a fact know that if I'm at 20 degree east, then by the time I reach prime meridian, I have to cover 20 degrees. How do I know this? From the definition of longitudes. I'll be covering 20 degrees at the center. From there, the total distance I have made to travel is 40 degrees 58. So if I know that this total angle is 40 degrees 58 and I know this angle is 20, if I subtract 20 from this whole angle, I will get the remaining, right? So I could just do 40 degrees 58 minus 20 degrees. So I get 20 degrees 58 minutes, but west, right? I end up somewhere here. So what are my coordinates? My coordinates are 20 degree north, 20 degrees 58 minutes west. Now let's say they had given us only the two coordinates of 20 degree north, 20 degrees 58 minutes west, and 20 degree north, 20 degree east. How much is the d long between them? It will be the addition, the total absolute angle between them. What do I get it? 40 degrees 58 minutes, right? So it makes sense. Fine. Now I'll give a question, okay? And I want you guys to think about it for a second. Let's say an aircraft takes off from a point X, which is 30 degrees north, 170 degree east, okay, and flies easterly, but flies for 3 hours at a ground speed of what? Of 400 knots. Again, what are the coordinates of destination? Anytime they ask you coordinates of destination, you know you have to find d long. That's the only way you can get your coordinates, right? So let's understand what the question is asking. So I have a prime meridian, but now please remember, I am looking at it from the complete opposite side. Okay, we spoke about this when we were drawing the earth initially. I am looking at the back face of the earth, the side which is the anti-meridian to the prime meridian, or what I call as the international date line, right? So if I look at the earth, okay, let me show it to you. What are we talking about? Okay, this is the prime meridian, the one you see on your screens right now, in the center, right? They tell us we are at 170 degree east. So when you come back to the meridian, do you see where 170 degree east is? It is to the anti-meridian to the prime meridian. The prime meridian is in front. We are at the back face of the earth, right? We are at the back face of the earth. Okay, so let's use this picture itself. What does it say? We are at 30 degrees north. So let's say, perfect, we have a picture. Fine. So what do they tell us? They say that we are somewhere here, right? 30 degrees north, 170 degree east. And they say we fly easterly. So now the question is, how do I measure east? So please remember, easterly is always going to be flying right. It doesn't matter. For you, flying easterly is always going to be flying on a heading of 090. What is a heading of 090? Where are you measuring 090 from? From your north. 090. That is this direction. Hence, any time flying right will always take you on the track of 090, or what I have given a name to be easterly track. Right? Fine. So, I have this one point which says I am at 30 degree north, 70 east, and I'm traveling eastwards. Okay, I'm traveling eastwards, and I travel some distance, which I have to calculate because they've given me the time and speed, and I have to find the coordinates of this point. Okay, now this line is only drawn to explain you. This line's length will completely depend on what value you get when you multiply speed with time of the given question. So if we look back at what we were drawing, 170 degree east was somewhere here, right? So we said 30 degrees north and 170 degrees east, right? Then from here we travel eastwards for some distance. How much is that distance? That distance is equal to whatever my ground speed is, which is in this case 400 knots, into 3 hours of flying time. So that's 1200 nautical miles, right? So I know my departure is 1200 nautical miles, but the same 1200 nautical miles traveled near the poles is going to take me much further, or is going to give me a much larger difference in longitudes than the same 1200 degrees traveled at the equator, right? That's why I have a cos of latitude. So coming back to the question, we have to calculate our d long. D long at what? D long at 30 degrees north. So d long is equal to departure by 60 into cos of lat. I have done nothing but just rearranged it. So how much is our departure? Departure is 1200. 60 into, what is it? Cos of 30 degrees. When you calculate this, you will get a d long of 23 degrees 5 minutes. Okay, fine. So let's say that there was some approximate line here, and that approximate line, this whole angle is equal to 23 degrees 5 minutes. That is what I calculated as my d long, or my absolute difference between the two longitudes, right? So what are the coordinates of this point? So one thing what I can do is, using basic crude logic, I know going from 170, this is the 180 degree line, or the prime meridian's anti-meridian, what I call as the date line, or 180 degree line, right? So going eastwards, I know I'm going to travel 10 more degrees before when I reach this line, and I have to travel some extra distance, and this total should be equal to 23. So I know this is equal to 23, and I know this is equal to how much? 10, right? I know that. So how do I get this? I subtract 10 from this whole angle. So what do I get? I get 13 degrees 5 minutes. So this angle is equal to 13 degrees and 5 minutes. Now, what do I do? Now, please remember, because you are traveling in this direction, the next line you're going to get is 180, then 170, then 160, then 150. Let's look at the earth, okay? Let's help you out. So, if you look here, crossing the anti-meridian, you come to 170 degree west now, then 160 degree west, then 150, then 140, then 130. You continue in that fashion, right? So, they say that now you've traveled. They say that now, according to the question, you have now traveled 10 degrees from here, and the remaining 13 degrees 5 minutes you have to travel here. So how much is that going to be? 180 minus some 13 degrees 5 minutes. What does it get you? Okay. If you calculate it, you'll realize you get an answer which is equal to 166 degrees 54 minutes. Right? That is the answer you get. I hope that makes sense. Right? Conversely, and I'm just sharing this as a tip, what you could do is just quickly imagine the earth as if you were looking at it from top down. Okay, you were looking at the North Pole. This was your prime meridian, and you are at the anti-meridian, which is here. You are at 170 degree east. You know you have to travel some angle. You don't know what this point is. You don't know it. But you know this angle is equal to 23 degrees 5 minutes. So what you could do is, of this total 360 degrees, you could just separate this pizza slice. Right? Of this 360 degrees, you could just remove this. You will get this point. Right? How much was it? So what did you want to measure? You know this was already 170. Right? You could measure another 23. This will give you 193 degrees 5 minutes. So of this total circle, if you were to remove this much, you will be left with what? Only this much. Measuring from your prime meridian, you will be measuring this angle. And what is this angle called? This angle is nothing but your longitude. I hope you understood what we did there. So going over it again, I know this is 170 degrees. I also calculated some x angle of 23 degrees 5 minutes as my d long. So of this total circle, if I were to remove this much segment, I know I'm going to be left with only this much angle. This angle is called what? This angle is nothing but my longitude. So you could also do that. You could also do 360 degrees minus 193 degrees 5 minutes. It will still give you 166 degrees 54 west. Of course, I've approximated it to 54. But when you calculate, you'll get a hang of it. Right? Fine. So, I'll give a question for you guys, which I want you guys to solve. Pause the video, solve it, and drop your answers in the comment section. If it's wrong, I correct you. If it's correct, amazing. So, the question is, an aircraft takes off from 45 degrees north, 170 degree west, flies on track of 270 degrees, flies for 2 hours 40 minutes at a ground speed of 360 knots. Find coordinates of destination. Alright, so take a moment, pause the video, think about how you solve this, and let me know your answers in the comments below. I'll leave this, pause the video. Fine. Now, if I were to explain you another model of questions, so far we figured out how to find the basic question of departure. We also looked at models where we were given other two details and we were asked to find our D-longs. Now let's look at what if we are given our D-long and our departure. What do we do to find our latitudes? And what do those questions look like? So the question says, after flying for 3 hours 20 minutes at a ground speed of 400 knots, the aircraft has undergone a longitudinal change of 40 degrees while flying along parallel of latitude. While flying along parallel of latitudes. What is this latitude? Find the latitude of aircraft. So, I have been given the D-long to be 40 degrees. I don't know what latitude I'm at, but I know my departure. How? I just do speed into time, which is in my case 3 hours 20 minutes into 400 knots. So how much is that going to give me? It's going to give me 33 nautical miles. Alright, so departure is equal to D long into 60 into cos of lat. Departure I know is 1,333. D long I know is 40. This I know is 60. This I don't know. I don't know cos of lat. So 1,333 divided by 40 into 60 is equal to cos of my latitude. So what do I get? I get cos inverse of 1,333 by 40 into 60, whatever that number comes. When I put my cos inverse function, I'll get my coordinates to be 56 degrees 15 minutes. Right? This is just the basic use of a calculator, of the Casio calculators that you guys will have and be able to use during your exams. But in case you want me to use it or tell you how to use it, just let me know in the comment section. I'll make a very quick video on how do we punch these numbers and how do we use that calculator. But very simple, right? You take the cos here, you get 1 by cos into this. 1 by cos is nothing but cos inverse of this whole number. When you punch it in your calculator, you get your lat to be 56 degrees 15 minutes. Then now there's a very interesting observation. Okay, I'll use the term observation itself. So this is again another kind of question. It's more like a riddle within your departure questions, and it takes a little effort, but it's extremely fun to solve these questions. So let's look at it. The question says, two aircrafts A and B, two aircrafts A, comma B, they both take off from some point X, which is 40 degrees north and 050 degrees east. They both take off from here for some point y, which is 50 degrees north. Okay, for some point y, which is 50 degrees north and 065 degrees east. They say aircraft A flies on easterly direction till longitude of 65 degrees east, then flies north, and B flies north first, then flies easterly till what? 065 degrees longitude. Okay, so A first flies east, then flies north to the point, right? Now if you observe, they both are not at the same latitude, right? One is at 40 degrees north, other is at 50 degrees north, right? So they say that one of them, A first flies east, then flies north, B first flies north and then flies east. So the question is which aircraft has flown longer? And by how much? Okay, so which aircraft has flown longer and by how much distance has this aircraft flown? So let's try drawing a diagram, and that will literally explain you 90% of the question. So we have a Earth, we have a prime meridian, we have an equator. Fine. Now they tell me that my point of x coordinate is 40 degrees north, 50 degrees east. So let's say it is somewhere okay, let's say that the point is somewhere like this. So let's say this is 50 degree east, and let's say this is some point which is 40 degrees north. This is my point x. Then I want to fly to a point y, which is at 50 degree north, 65 degree east. So it's further east of me. Okay, so this one is 65 degrees east, but it is outside a different latitude, which is at 50 degrees north. This is point y. Now if I were to just zoom within this portion, okay, then you will realize that aircraft A first flies eastwards, then flies north to reach this destination, and aircraft B is flying north first and then east. Who do you think has flown lesser distance? Take a moment, observe this picture. Aircraft A first flies east, then goes north. Aircraft B first flies north, then flies east. Which aircraft do you think, visually, has flown longer? Is it alpha or beta? Pause the video, drop your comments. It's okay if you're going to be wrong. It's just going to make the whole process more fun. Right? So, the answer is that A has flown a longer distance. Why is that? Because logically, if you think, because these both are meridians, right, and they both are bound by the same latitudes, then the distance between them, or the CH lat, is it not the same here and here? The CH lat, something we studied in the last class, it's the same here. So the vertical distances they are both going to travel is going to be the same. The only difference in the distances that they will ultimately travel is going to come from their horizontal legs. right? And knowing that these both converge, I know that B is going to travel much shorter distance horizontally to reach 065, whereas A has to travel much further to reach 065, right? So let's get down to calculating these things. Okay, so one method is to calculate from A, calculate your your departure to point this, because the coordinates, it's going to be 40 degree north, 065 east. Then calculate this difference of 10 degrees here, 50 to 40. So 10 degrees, each degree 60 nautical miles, so this is 600 nautical miles. Add both of these vertical legs are going to be 600 nautical miles and 600 nautical miles. We just try to find out these horizontal legs. So let's do a thing. Let's name this quadrilateral something. Let's name it P, Q, R and S. Y lies on point R, X lies on point P. So departure P to Q, if I calculate departure P to Q, okay, which is from 40 degrees 50 minutes east to 40 degrees 65 east. In this case, I will get my D long to be what? My D long is 15 degrees 60. What is my cos of flat? Cos of 40 degrees. So what do I get my departure to be? My departure comes out to be 690 nautical miles. So this leg is 690, right? I know this is 600 and I know this is 600. Why? Because there's a 10 degree difference in CH lat, and 10 degrees equates to 600 because 1 degree is equal to 60, right? Then let's calculate between point S and R. Okay, so let's calculate departure between point S and R, which is what? 50 degrees 65 minutes east to 50 degrees north, 050 degrees east. How much is the departure here? It's going to be 15 into D long of again what? 15 degrees into 60 into cos of 50 degrees. So what did I get here? I got 578.5. Now because vertically they both are going to travel 600, right? The difference is only going to come because of the horizontal legs. So how much is the difference between these two legs? How much is it? The difference between these two legs is of 111.49 nautical miles, right? That is the difference between the two legs. Okay, so this is the difference. Who travels longer? A travels longer, right? So there's a very important observation here, that whenever you're given two aircrafts which take off from the same point and head to the same destination, and we are asked that who has traveled longer, then the aircraft which has flown at a latitude which is closer to the equator ends up flying more, since the cos value in departure formula increases with a decrease in latitude, right? The cos value increases with a decrease in latitude. Cos 0 has the greatest value. The D long is going to be the same. 60 is a constant value. The difference is only going to come because of the values of cos. And the values of cos are greater closer to the equator, which in turn means that the aircraft which is flying its horizontal leg closer to the equator is going to end up flying more, always, right? Now there was also a simpler method to solve this whole question, right? If you think about it, okay, if you think about it, what we could have also done, right, we could have just found the ratio, right, we could have just found out the ratio between the two halves, the two sides. How? Okay, let's say P to Q, I had calculated some departure, and R to S, I calculated some departure. This is what I did, and I found the difference between the two. These departures are a function of what? Let's write it down. Departure is equal to d long into 60 into cos of lat. So departure P to Q will be equal to d long. Okay, d long of 15 degrees, in our case 60, into cos of what? 40, right? Similarly, departure R to S will be equal to 15 into 60 into cos of 50, right? So when you divide it, okay, when you divide it, you'll realize key departures are nothing but a function of their cos values. Departures are nothing because everything else is common. Okay, where will you understand the significance of these kinds of questions are if, okay, I just introduced you to a model. Let me just give you a question. Okay, so write it down and try solving this on your own. Aircraft takes off from (45 degrees north, 050 degrees east). Okay, flies on track 000 for 600 nautical miles. Thereafter flies for 090 track for again 600 nautical miles. Then flies on a track of 180 degrees for 600 nautical miles, and then flies a track of 270 degrees again for 600 nautical miles. The question is find aircraft position, okay, with respect to starting point. Will it be east, west, north, south of its starting point? Then B, find coordinates of its destination. So the question says I start from some point X and I travel north for 600 nautical miles. Then I travel 090 or east for 600 nautical miles. Then as soon as I finish 600 nautical miles, I turn south and I travel 600 nautical miles. And then I travel west for 600 nautical miles. So they asked me, where will I finally end up? Will I end up to the east of my starting point, west of my starting point, north of the starting point, same position of my starting point? Where am I with respect to my starting point? The B bit says, fine, wherever you are, find the coordinates of this point. So think about it. We've discussed enough to help you understand and gauge what is to be done in this question, how to approach and solve this question. So please try doing it. And drop your answers in the comment section. If you're ever stuck, drop that also in the comment section. And I hope you guys have understood what departure is. It's an extremely important chapter to set the foundation. And if there's anything I can help you with, please let me know. I'll see you in the next class.